Hello. Alright, do you remember the factors that affect the rate of reaction? Okay, so they are temperature, pressure, particle size, concentration, and of course, catalyst. Okay, so these are the 5 factors that affect the rate of reaction. Okay, so when they ask you in a reaction, usually they will give you any random experiment. The simplest one is just using a test tube, okay, and putting, so remember, if we are measuring the differences when different temperatures as the factor, everything else must be the same. So for example, these 2 test tubes must have the same volume of acid, let's say 5 centimeter cube, hydrochloric acid, same concentration of acid, 0.1 mole per decimeter cube. Alright, and the amount and the size of whatever metal or whatever you're using has to be the same. So let's say 1 gram of magnesium ribbon. Now what happens is you test your stopwatch, you on your stopwatch, and you have one at 25 degrees Celsius and another one at 45 degrees Celsius, let's say. Okay, so all you need to do is measure the time taken, or just have to compare which one finishes first. Okay, so what will happen is the magnesium will dissolve in the hydrochloric acid to produce magnesium chloride and release hydrogen gas. Okay, so magnesium here is a solid, and what happens is the solid will dissolve to form magnesium chloride. So this magnesium ribbon will get smaller and smaller and smaller. So obviously the one that is at a higher temperature will be faster. So for example, this one will probably take, let's say 30 seconds, and this one will take up to 90 seconds, for example. Okay, so when the temperature is higher, the rate of reaction is higher. Okay, so why? Obviously when the temperature is higher, the particles are moving faster, so they will collide with the magnesium faster and the reaction occurs faster. Okay, now for temperature, that's temperature. Pressure only affects gas. So it's only when your reactant is a gas. So remember, for pressure, the reactant is a gas, not a temperature, not the product. So what happens is, for example, if hydrogen gas reacts with iodine gas to form hydrogen iodide, which is also a gas. Okay, so what you do is, if the whole system is under high pressure, the rate will be much higher as compared to using a lower pressure. Okay, so they don't really ask you this normally for lab experiments, because you can't really do pressure in the lab. Okay, so the next one is particle size. Now this is something fun. Okay, so the easiest one to differentiate is, of course, you can use calcium carbonate powder, and of course calcium carbonate pieces. So they both have to be the same mass. You have to have the same acid. So let's say hydrochloric acid, 50 centimeter cube, 0.1 mole per decimeter cube. Okay, so you can measure the rate of reaction, who releases more gas faster, which one the calcium carbonate dissolves faster. So the same thing is that the one with calcium carbonate powder will be much faster, because when the particle size is smaller, it will have a larger surface area. So I'm sure you've heard this word before, surface area. Okay, larger surface area. Now, where do we use this in everyday life? So for example, if we are cooking a chicken that is cut into smaller pieces will cook much faster. Okay, Now, what happens is that in a sawmill or a flour mill, okay, the particles of sawdust or the particles of flour are very, 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 very tiny, and they're just floating in the air. Okay, now if you had a piece of wood, it would burn, but it would burn slowly. If you had flour, which is basically a carbohydrate, it will also burn, but burn slowly. But when it's spread out and it's in the air, and some person who's not really smart goes to the factory or goes to the saw mill or the flour mill and lights a cigarette or just lights up a fire, what happens is this whole thing will explode, because the particle size is so small that there's so high rate of reaction that the whole thing will become an explosion. Okay, so that's really, really dangerous. Now, so that is for particle size. For pressure, where do we use it in everyday life? Because I just told you, we don't usually do experiments like this in the lab, but we do it in the kitchen for a pressure cooker. The whole concept of a pressure cooker is when you have a pressure cooker, it is sealed tight. So therefore, the air pressure doesn't go out. It causes the pressure to increase inside the pot. The temperature increases, the pressure increases, and everything will cook really, really, really fast. Who is the gas here? The steam. The steam released by the food. Or even if you're making a porridge or anything, there's water inside. So the water will become steam, and this gas causes the pressure to increase. Okay? Now, so temperature, pressure, particle size, concentration. So obviously, if the concentration is higher, the rate of reaction is higher. That's a no-brainer. Okay? So we can use this by, again, we can do acid. So for example, we can just take sulfuric acid and we can take a piece of zinc. Okay, so remember, your zinc has to be the same size. Now, sulfuric acid, same volume. Let's say 50 centimeter cube, but different concentrations. This could be 0.1 mole per decimeter cube, and this could be 0.5 mole per decimeter cube. So obviously, the one with the higher concentration will be much, much faster. The rate of reaction would be higher because there are more particles in the same volume. Now, we can't just say more particles. We say more particles in the same volume. So if the red color are the particles of acid, a higher concentration will have much, much more particles in the same volume. A lower concentration will have less particles in the same volume. So what happens is when there are more particles, they collide more often with the zinc piece, causing the rate of reaction to be higher. Alright, now the final one is catalyst. Now, catalyst is really fun. What happens is we usually use hydrogen peroxide. So do you guys remember the reaction of hydrogen peroxide? So hydrogen peroxide decomposes to become water and releases oxygen gas. Okay. However, this reaction is really, really slow. If you bought a new bottle of hydrogen peroxide and you opened it, it will maybe see 1 or 2 bubbles, tiny, tiny bubbles. So what you do is you add a catalyst. Now, the catalyst specifically for hydrogen peroxide is manganese 4 oxide. Okay, so you need to remember the name manganese 4 oxide. Okay, so manganese 4 oxide is a black color powder. So when you add it into your hydrogen peroxide, it will start to bubble like crazy, and it will actually have very interesting reaction. Okay, so it'll try to bubble like crazy and releases lots and lots and lots of oxygen. So how do we know that this hydrogen peroxide is a catalyst? Because at the end of the reaction, you will still see the exact same amount of manganese 4 oxide. You can filter it, wash it, dry it, it will be the exact same mass. It is not used up, it only increases the rate of reaction. So these are the 5 factors. We've just gone through very, very quickly the 5 factors that affect the rate of reaction. In my next videos, I'm going to talk about the collision theory. the theory behind the rate of reaction. Okay, see you.